Hi guys. So in this video, I will be explaining with you some top 15 multi-threading based tricky questions that is most commonly asked in interviews. Okay. So what all type of questions that can be asked to freshers as well as for experienced, that type of questions I will be sharing with you completely in depth. So let's understand what all questions can be covered. Let's get started. So now let's get started with top 15 multi-threading questions for freshers separate and for experienced separate. Okay. First, we'll be going ahead with the freshers. Okay. So these type of questions are most commonly asked, like what is a thread in Java and how is it different from a process or a task? So this is most commonly asked question to freshers. Even for experience, sometimes this question can be asked. Okay. So process is nothing but how you are executing a particular task. Okay. The entire set of executions that is being done by the OS that is being coming under process, and thread is just a part of the process. Okay, and task is the instructions that is being executed that is coming under the task. So each and every words here are very important: thread, process, task. So you should be very much aware of it. Okay, next question. Next is coming like, how are you creating a thread in Java? There are various ways to create a thread, right? No, there are just two ways to create a thread in Java. First, by extending thread class and by implementing runnable interface. Okay, so when to go for extending thread class and when to go for implementing runnable interface, that also we have to understand. So if there is a requirement, just like there is only one class to extend and we don't need to extend any other class, then we have to go for extending thread class. When we have to extend a class, then apart from that we need to implement also multiple interfaces, then it will be very much difficult. Okay, if you are going ahead with only thread class, because one class can extend only one class at a time, right? So if there are multiple classes, you won't be able to extend that. Okay, so in that scenario, runnable interface will be helpful. So we have to see like when to use what. So generally we are implementing runnable interfaces. Okay, so within that we have to implement run method. Okay, so run method executes all the jobs. So here also there can be separate set of questions based upon that. Like if I am writing, if I'm not overriding run method and we are starting the thread, then what will happen? So that type of question can also come, right? So in the main method, you are starting the thread like t1 dot start thread t1 equal to new thread. You are passing that task, and after that you are starting the thread with t1 dot start, and you have not overwritten the run method. Then what will happen over there? If you are calling the run method directly without creating the without calling the start method, then what will happen? That type of questions can also be asked. So those questions you should be very much aware of it. Okay, so if you are not overriding run method, that doesn't mean that it will start throwing any compile time error or anything. Okay, so it will be executing the normal process. Like if nothing is being implemented, it's totally fine. Okay, still it will be printing the default condition, default things which are being there. Okay, so if we have not written anything in run method, it's totally fine. Okay, so that is the thing we have to understand. So what are the states of a thread in Java? So whenever a thread goes to a particular life cycle, there are different instances through which it goes. First is the newborn thread. Whenever the thread is being born newly, okay, that means you are creating a new thread, like thread t1 equal to new thread you are doing. Okay, so like that, it creates a newborn thread. So it will go through this new. Okay, after that, when you are starting the thread, it goes to the runnable state. Okay, as soon as you're starting the thread, it goes to the runnable state, and within that we are just getting ready. The thread is just started getting ready to run. Okay, so now after that we'll start running the thread. Okay, so after that there can be like multiple stages, like it can either go to sleep state or wait state. Okay, or yield. There are multiple methods. Then again questions will come on these methods. What's the difference between yield method and the sleep method? What's the difference between sleep method and wait method? These kind of questions can come. And there is something called as join method also. Questions can come from join method as well. What's the importance of join method? So if you are making use of join method, then it will give the priority to that thread which is having the priority which is having equal to that particular thread, or more than that, not less than that. So that's the importance of join method. Okay, so whenever you are adding join method over a thread, so it will allow the other thread to execute first if that's priority is more than that particular thread. Okay, or else this particular thread only will work. So like that, you have to understand. And then there are other methods of the object class, basically, like wait method is there, notify method is there, notify all method is there. So these all are the methods of the object class. And sleep method is there, that is coming from the thread class. Okay, so these are the difference between sleep and wait method as well. Okay, so what's the difference between the two? One is helpful for resolving deadlock, another is not helpful for resolving deadlock. So just go through those differences. That type of question can also come. Okay, so there can be like blocked state, then waiting state, then timed waiting state. And after this entire set of stages, internal stages are getting completed, then it goes to terminated state. Okay, so it exits, the entire process gets exit. So there are new thread, then it goes to runnable state, then the blocking state is there. Within blocking state, it can have multiple stages like yield, sleep, wait, join, then notify all these. Then wait is also overloaded method. There is a 3 overloaded method within wait. So that also we have to learn what all overloaded methods are there. Okay, then at last it gets terminated. Okay, so these are the basic 3 to 4 states of a thread. What's the difference between start and run method? That I have little bit told you before as well. So start method creates a new thread, and for run, no new threads are getting created. Okay, so as soon as you creating a run method, so it will work like a normal method. It will not work like a thread run method. Okay, because thread run method will get executed when you are calling start method. Okay, in a class which is a thread class. Okay, an execution context from that perspective, if I see, like it runs, start method runs the run method in a new thread, and run method runs the run method in the current thread. Whatever the current thread is there, on the basis of that, it will run the run method. Okay, then it enables concurrent execution. The start method enables a concurrent execution of the task, and run method it executes sequentially. Okay, so whatever the thread is being called, it will call one by one. Okay, it will not call, it will not have a concurrent execution of the task. Okay, for start method, it creates a separate call stack. There will be a separate call stack as soon as the start method it gets executed. And for run method, it uses the same call stack which has been called by the caller. Okay, so there are certain key takeaways that we have to learn over here. Like always use start method when you have to execute a code in a separate thread altogether. Okay, and directly calling run method, it defeats the purpose of threading. Okay, when you are calling run method, it will work as a normal run method only. The task execution will be sequential, not concurrent. So what's the point of using multi-threading if you are doing sequential task execution? Okay, so that's why whenever you have to go to concurrent task execution in a separate thread altogether, then go for start, or else run method is there, like which will work like a normal method. Okay, so this is a thing that we have to understand. Next, what is the purpose of synchronized keyword? Okay, so synchronization acts in various stages. Synchronization works at a class level, it may work at a method level, then it may work at a field level. Okay, so at each and every level, there is a specific importance of that. If you are putting synchronized over a class level, then it will lock the entire class. Then if one thread is coming to acquire the lock, it will lock the entire class, just like the synchronized hash map. What we have learned in synchronized hash map, whenever one thread is being coming over there to lock the object set for a map, it will lock the entire set of objects, like 16 objects are there. Okay, in hash map size is 16, right? It will lock entire set of buckets. And once the thread execution is completed, then it will give chance to another thread to acquire the object lock. Similar to that, synchronized class is there over a class. If you are putting synchronization over a class, one thread will acquire the lock on the entire class. Second comes when synchronization, you are putting it over a method. Then what will happen? Whenever you are putting synchronization over a method, then all the lines written within that method will get multi-threaded. Okay, all the lines will get executed depending upon what type of operations you have provided. So if you have provided synchronized over a method, an entire set of lines will get synchronized basically. Okay, it becomes thread safe. So it actually slows down the process. Why? So let's suppose in a particular method, there are 20 lines, and out of that, only 5-6 lines are being made for synchronization. Then rest 15 lines, why we should synchronize that? In that scenarios, synchronization over a method, it slows down the process. Yeah, so how can we resolve that? We can have a synchronized block. If you are writing synchronized block within that method, then it will focus only on that particular block of statement, not the rest of the lines of code. So it increases the productivity of that particular code. Okay, so the lines of code will be executed much faster as compared to the previous state where you are putting synchronization over a method. I hope you got a clarity on this. Next, what is a thread safe class? Okay, so there are various kind of threads, like, so we can have a class. So how can we make a class a thread safe class? So we can make use of synchronization. Okay, we can have a synchronized over a particular class, or we can have a block of statements. Okay, and we can make a class a thread safe class by extending thread class first. Okay, and then with a proper usage of synchronization, we can make a class a thread safe class. Okay. For example, for array list, if I say array list is not a thread safe class, what we can use to make it a thread safe, we can have copy on that array list. It will become thread safe. Okay. So, and with respect to hash map is not thread safe. Then we can go ahead with concurrent hash map. It becomes a thread safe class. These kind of things they can ask you instantly. Okay. So you should have the idea like how can you explain the concepts to them. I hope you are getting the clarity on this. Yeah. So these are the questions like what are the deadlocks and how can you prevent them? So deadlocks, I hope you are knowing this. So if one thread has acquired a lock on one of the resource, okay, and at the same time, second thread has acquired a lock on the second resource, okay. So what will happen? So thread one will wait for the second thread to release the object lock from the second resource, and the second thread will wait for the first thread to release the object lock from the first resource, and both will wait for the infinite period of time. That is the deadlock. So how can we prevent them? So we have to properly write the synchronization. Okay. So we have to separately write synchronization over a particular method or block depending upon how you are implementing it. So basically we are putting it at the method level because we are not writing much logic in that method. So like that, if we are putting and proper usage of synchronization, if you are not doing, again, it will go to deadlock state. If you want me to create a specific video on deadlock state, try commenting it down below. Okay. We'll be creating separate video on that. And how can you prevent that? I already told you with the help of synchronization. Okay. Race condition. I hope you are knowing this race condition, right? I don't need to tell it again. So basically, if you have like multiple threads who is acquiring the lock on a particular block of code, okay, so it may happen that second thread's lines are getting printed first, then first thread lines are getting printed later. So there is no proper synchronization between the lines. So some lines which should be printed first, that is coming at last. So these things, there is some inconsistency across the lines of code. So this thing can be resolved with proper usage of synchronization. Apart from that, the initial state where it is not printing properly, it is called as the race around condition, where the consistency is not there in the output. There will be data inconsistency. Okay. So this is the race around condition. Then what's the difference between wait, notify, and notify all? Okay. So here, if you can observe, I have written it down for you all to know the differences between all three. So you can pause and you can go ahead to learn about all these three. So main thing which I wanted to tell you, like wait method, it is the, basically from the object class, all are from mostly from the object class only, but wait actually helps us to resolve the deadlock situation. Okay. So wait method will apply when we want a particular thread to wait for a certain period of time. And as soon as the process of that thread is completed, it needs to get notified to another thread ki, yes boss, my task is being finished. Now you can come ahead and you can allow other thread to execute. Now I am going to the relaxed state. Okay. So it will just notify to that particular person or the thread. So this is the notify method. And if you want to notify to all the threads, then we have to move ahead with a notify all. So similar to that, there are multiple differences that you can go ahead with. So you can just go through the differences. You will get to know the understanding, like what's the major difference between all these three. Okay. So how does the join method work in threads? This is a question that I've already discussed, I think. So it will give priority to the other thread which is having same or the higher priority level. Okay, so it will give chance to that particular thread. So this is basically the advantages of join method, and you should go through it, like how we can use the join method in the thread. That also you have to go through it. Okay. So you can just go through some of the examples in Google. You will get to know like how we can implement the join method, because that also can be asked. Okay, so basic concept should be very much clear. Next come what is a thread priority. Okay, so we can allow a particular thread to give the priority to certain set of tasks. Okay, so if suppose I want to give this particular thread a certain priority, like either 0 to 5. So priority level is being set like 0 to 9, some priority is there. Okay, so if the thread priority is 0, that means that particular thread is not at all prior. Okay, if it is 9, it is like highest priority. So like that, we can set the priority with thread.set priority. There is a priority method is there within the thread class. Okay, the three methods are there. There are like three states: ID, name, and priority. We can set, and for priority, we can set it explicit. Okay, so these are the things that we have to put ahead with. So what's the difference between volatile and synchronized keyword? Okay, so this is also very important for interview perspective. So volatile, basically we are making use in the multi-threaded application. So if you have gone to synchronize singleton class, so there if you want to make a singleton class multi-threaded, okay, in that scenario we are making the field reference as a volatile. Why? Because you want the visibility to get guaranteed across all the threads, so that if one thread is making any kind of difference, then this difference should get notified to all other threads parallelly as well, right? So how will that happen? It will happen when we are making the field reference as volatile. As soon as we do that, from the name itself, it is understood that it is volatile. That means it is evolve. Okay, it will vaporize and it will give information to all the threads. You can just imagine like that. Volatile means it's easily evaporated and it's give information to all the threads. So like that you can imagine. Okay, and synchronize, like it ensures that it's both visible and atomic in nature. So both it will confirm. Okay, so from scope, volatile applies only to particular variables or field, but synchronization applies to methods, block of code, classes, everywhere. Okay, and from atomicity, volatile keywords or volatile does not provide or guarantees atomicity, but synchronized guarantees the atomicity of the operation within the synchronized block or method. Okay, with respect to visibility, volatile guarantees the visibility, synchronized guarantees the visibility of shared resources when exiting the synchronized block. When it is exiting from the synchronized block, then it will guarantee the visibility, or else it will not guarantee. But volatile will guarantee the visibility of the latest value which the particular variable process. Okay, once you are putting volatile over a field, it will provide a guarantee that whatever the latest value has been set for that particular field variable, it will be visible to all other threads. Okay, from thread locking perspective, volatile does not involve any kind of locking, but synchronization, it involves locking, as you all know it. Performance, volatile is very lightweight as it doesn't make use of any lock, but synchronization, it can be costly because you are making use of lock concept over here, and so there will be context switching. Okay, and use case, for variables when only visibility is required, it needs to be guaranteed. Okay, and for synchronization, it is required for critical sections which requires both atomicity as well as visibility. Okay, so scenario I have put it down for you. When there is a visibility and atomicity, need visibility without atomicity, then go for volatile. If you need atomicity, then go for synchronized. Okay, for if you need only atomicity, then go ahead with synchronized. Okay, volatile is not required. If there is a minimal performance overhead is required, that means multi-threaded is not that much required, then go for volatile. Okay, synchronization, it incurs little bit overhead. Okay, and complex operation of multiple variable updates, if it is required, then go for synchronized, because variables will get updated over every lock. Okay, and for volatile, it's not required for complex operations because it is very lightweight. So these are the common differences between volatile and synchronized. I hope you got the clarity on. How do you stop a thread in Java? So there are multiple ways to stop a thread in Java. Okay, so with the help of volatile flag. So if you are creating one boolean volatile flag, okay, so it actually signals the thread to stop it. Okay, so advantages are like it is very lightweight, so there is no thread interruption overhead, and disadvantage, it requires periodic flag checking. Each and every time you have to check whether the flag is true or false. Okay, so we can have stop method for the start task from the main method. You can call the stop method, and then it will stop the execution. Okay, then using interrupt method, so it interrupts the thread by setting its value. Okay, for interrupt there is a status, we have to set the status and we can stop it over there. So it must be handled with interrupted exception because it may throw interrupted exception, so we have to handle it or catch it in try catch, or you can throw it in the method declaration. Okay, so this is a thing, so we can call interrupt method from the thread. Okay, then executor or shutdown, it's an executor framework. Basically we can call the executor service shutdown method. We can have executor service es equal to executors dot new fixed thread pool, and then from that reference you can call the shutdown method. Like that you can do the shutdown. This is basically used in the project level. Okay, and stop method directly we should not make use of. It is not similar to task dot stop, it is thread level dot stop method. Okay, so it immediately stops the execution of the thread. That's why it is not recommended to use. Okay, because it's unsafe and it may leave the resource in the inconsistent state. That's why it is not commonly used over in the project basically. Okay, I hope you got the clarity. Next is what a daemon thread. So daemon thread is something which is going in the background. Okay, so which you have not created it, but it is going on in the background and it will be there until unless your entire program gets over. Okay, so it will from here you can understand, like they do not prevent the JVM from exiting until unless JVM is running. Till that time daemon thread will be running, but there is one more thread called user thread. Okay, so user thread will be running until and unless the application is getting executed. Once the application execution is completed, then user thread will automatically get completed, but that doesn't mean that daemon thread will get completed at that point of time. So there is a chance that when user thread gets completed, JVM is still running. So if JVM is running, the daemon thread will run, but user thread will stop. Okay, so daemon thread will stop when JVM will stop. So that's the difference between daemon thread and user thread. I hope you got that clarity. Now, next, understand about what's the executor service. Okay, the executor service is a part of executor framework which has been created as a separate section in a multi-threaded concept. Why? Because thread creation is very costly, right? You can normally in Java you can create extending thread class or implementing runnable interface. At that point of time, what you are doing, you are creating the object of a thread class, like thread t1 equal to new thread. You are passing the task over there, then you are calling the start method. So that start method is a little bit costly. Okay, creating the object of the thread class each and every time depending upon how many tasks are there, you don't know, right? There can be millions of tasks, there can be millions of processes. So can you create that many amount of threads? Will that be possible? No. That means the creation of thread is very costly. So if creation of thread is very costly, then we should not go ahead with it. It's very time consuming and it is very much costly. So why we should pay that much when there is one option is there? What option is there? Tell me, guys. Executor framework option is there. So within that, we can create a pool of threads. So you can understand like there is a small swimming pool. In small swimming pool, we can have water, we can have fish, we can do fishing over there, and we can have my stomach full. So you can understand similar to that. So similar to that, there will be like a particular thread pool. Within that thread pool, we will be having certain number of threads assigned depending upon the availability of our cores, how many cores are present in our system, and then depending upon that we can run those threads. So we don't have to create the thread multiple times. Once we have created this fixed thread pool, there are various type of thread pool that also you should go through that: fixed thread pool, caches thread pool, scheduled thread pool, single thread pool. Okay, so those, and by default it's fork joint thread. Okay, if we are not defining any kind of thread pool, then by default it will be fork joint thread. Okay, that we should remember. So executor service is a part of the executor framework which is coming as an extended family of multi-threading application, where there is asynchronous application, asynchronous execution of tasks is been happening over there. So it actually simplifies thread management because we are not creating the thread each and every time, where rather we are accumulating the pool of threads to that particular thread type, which is fixed thread pool. So for each and every task, there is a separate set of threads which has been defined for us. Okay, so these are the specific type of question that can be asked for pressures, and some coding question also I will be telling you. Like, let's suppose you want to print, so some deadlock related question can be asked, like can you implement deadlock scenario and how can you resolve it? That is one type of coding question. Another type of coding question can be like, if we have two threads and with two threads you have to print a b c d alternately, how can you print that? Or with two threads I want to print, like if one thread is printing odd numbers, another thread is printing me even numbers, how can you implement that? So those kind of multi-threaded question can also be asked. Okay, so you can practice on those terms as well, and some on the bit of synchronization and lock concept. If synchronization was already there, then why lock came in picture? So these things we have to focus upon. Okay, so these type of question can be asked for freshers. Now let's understand what type of question can come for experienced candidate. Okay, what is thread starvation and how it can be avoided? So this is a little bit advanced level question, but you can go ahead with it if you want to know as a fresher, if I'm telling you. Okay, so thread starvation occurs when one or more thread actually denies the access to the CPU or the necessary resources. So it prevents the particular thread from making progress. Okay, so this is often caused when there is a high priority threads which is monitoring the CPU resource. So there is like lower priority threads, it will be remaining there without any use. That means it will be starving for the task, but we are not providing them the task because access is denied. So this process is called as thread starvation. Okay, so now what's the difference between callable and runnable? Okay, so this can also be asked to freshers as well. Okay, but for experience, this is 100% these questions will be asked. Okay, what's the difference between callable and runnable? So the basic difference is what? Runnable is having run method, callable is having call method. Call method means it will return some data to the caller method, but run is of void type. It doesn't return me anything. We have to print there and then and there itself if you want to return any data, if you want to process any data. We have to write within the run method. Okay, so these are the basic difference which you can go through, and there are some other differences which you can go through as well. Okay, both are functional interfaces mainly. Okay, and one handles exceptions, one doesn't handle. So these are the three major differences. Callable is there in concurrent java.util.concurrent package. Runnable is there in java.lang package. I hope these four differences will be fine, or else you can go through the entire list which I have been given to you. You can pause the video over here, you can go through this video. Okay, now next, what is fork joint thread pool? So fork join thread pool is a by default thread join pool which has been assigned to us, which helps us to process the execution of a task depending upon number of threads being assigned to that process. Okay, so if that like fixed thread pool is not being assigned, particular thread pools are not being assigned. So in that scenario, when you are running the executor service, default fork thread join pool will be executed. Okay, so there will be like a worker thread, there will be a slave thread, master thread. So these things we have to understand. What's a worker thread? What's a slave thread? Okay, the relation between the two. So these things will come after understanding of fork join thread pool. Okay, then concept of work stealing in the fork or join framework. Okay, so what is that work stealing? That you should go ahead with. This is a very important concept. If you want me to create a specific video on that, do let me know in the chat box. Okay, because this is a lot of concept that we have to discuss. We can't put it explicitly because in this video it is specifically for different kind of question that can be asked in interviews. Okay, if you want me to create videos on that, do let me know in the comment box. Then reintrant block versus synchronized keyword. So there is synchronized keyword, then why lock came into picture? If lock came into picture, then what is a reintrant lock? Okay, so these things, these type of questions are most commonly asked. Okay, difference between read write lock and reintrant lock. Okay, so if someone is writing, then someone will not be able to read it. Okay, so it will be locked during that phase of time. Then synchronization, you can't able to synchronize another method. Let's suppose one method is synchronized, that particular method only will be synchronized. But lock, you can move from one method scope to another method scope. That's a major advantage of making use of lock. So these differences should be there in your mind. Okay, reintrant means you are entering that same particular lock state again. That is a reintrant lock. Okay, so these differences you should just go ahead and try to understand the differences between them. Okay, countdown latch versus cyclic barrier. This is also most commonly asked questions in Spring Boot, in multi-threading, sorry, in multi-threading concept. So this should be very much aware of. So how cyclic barrier works. Okay, so calling the same process, and once the same process gets completed, again it is calling the same process. So it is in completion stage until unless the entire set of tasks been completed. Okay, so countdown latch, there is one separate method that has been there. There is a countdown method that has been executed. So as soon as the countdown starts, okay, once the process gets executed, then countdown gets started. After the countdown gets completed, it will not execute the same task again. So there are certain other differences as well. You can go through the differences, you will get to know. Okay, semaphore versus lock. This is also important difference. This has not been asked much, but yes, they can ask. And if we are giving 20 interviews, then 18 interviews they will not ask. Only 2 or 3 interviews they can ask about semaphores. But this is important from interviews perspective, so you can go through that. Okay, how completable future is better than future. Okay, so you can basically chain multiple futures together. In case of completable future, you can handle exceptions well. Okay, you can return the response like some default message if it is taking longer time for future to give the response. So these are some basic difference where completable future actually is helpful. Okay, you can chain multiple future together. That is the major advantage. Okay, so yeah, you can go ahead with it. You will get to know a lot of things as a difference. And this completable feature came as a new feature in Java 8. Okay, so if you go through that, you will get to know like a lot of new things are there in completable feature. Okay, how Java's thread pool executor manages the thread. So there is a thread pool executor, right? So there is fixed thread pool, cached thread pool, scheduled thread pool, single thread pool. So in single thread pool, it's like a synchronous task. One task can be solved at a time. Fixed thread pool, for one particular fixed thread pool, it will create a pool of certain number of threads, like 10 threads, 20 threads. Depending upon how many tasks are there, you can create a separate set of threads, but you have to see the core process availability, like how many processes are there. Based upon that only, you have to create that many amount of threads. You should not surpass the core processor availability. If else, if you are doing that, it will not work properly. Okay, so this thread pool executor is a part of executor framework. So you have to understand like why it has been implemented and what's the importance of that. I've given you some knowledge before this topic as well, so you can go through that as well. Okay, concurrent hash map versus copy on write array list versus blocking queue. Okay, so if you go through producer consumer problem, their blocking queue will get into picture, and this entire executor framework, okay, it will work on the principle of blocking queue. So what is this blocking queue? This is also very important question for interview perspective. So what is blocking queue? Basically, it is like first in first out, normal queue if I consider. But in case of blocking queue, what will happen? So when there is no particular elements into that queue, then we should not be able to fetch any data out of it. But and the same time, if all the blocks are being filled, okay, then we should not be able to enter any data into that particular thread, sorry, queue. So this is basically how the blocking queue works. Normal queue, it will not check whether that queue is empty or whether that queue is full. These things it will not check, but in blocking queue it will check. Okay, so this creates a very big advantage, okay, normal queues. So in case of executor framework, we are implementing blocking queues. Okay, and concurrent hash map and copy on write array list is actually thread safe operations. Okay, so it will be a fail safe iteration. Whenever you are implementing copy on write array list, it's a fail safe iteration. And concurrent hash map, it actually creates a lock on a particular block only. It will not create a lock on the entire set of buckets of the hash map. Okay, so this is the advantage of concurrent hash map. Okay, so what's the difference between them? They can ask you. So generally they will ask about synchronized hash map versus concurrent hash map, or weak hash map versus identity hash map. Okay, and the copy on write array list, why it is used for, this kind of question can be asked, so you can go ahead with it. Okay, so these are the common difference that I have shown you. You can implement that. So once I have shown you like wait, notify, all difference between sleep method and wait method, then difference between wait method and await method, sleep versus join method, sleep versus yield method, what's the difference? So you should go through that as well. Okay, how do you identify and debug multi-threaded issues like deadlock or race condition in production? Okay, in production we can't debug over there, right? So how we can implement, how we can see where is the issue coming? Okay, so you can go through Kibana logs. In Kibana logs, you can get to know like where exactly your issue is there. There will be logger implemented. So through loggers, you can get to know like which all lines has been printed, which all lines has not been printed. From there, you will get the idea. And then in the local, you can set up the debugging part of your application, and then you can start debugging in your local as well. And you can mutate the similar scenario which at the production level the issue was there. You can you can mutate the similar kind of scenario. Okay, yeah, so this is the way basically you can identify and resolve the issues in the production level. Okay, what's that thread life cycle that I've already discussed, like new runnable state, running state, then pause state, then blocked state. Okay, then exit. Then producer consumer problem, like there is a producer who will continuously produce the data. Okay, and there is a consumer who will keep on consuming the data. So here blocking queue comes into picture. So it will not consume the data once the queue size is full. Okay, and once the queue size is empty, it will not give the data to the producer. So blocking queue is implemented over here, and wait and notify is also implemented over here. Like producer will send the data consistently. Okay, and then wait method should be there, so that wait method will notify to the consumer key you can wait for a certain time, because producer is not free to produce data. Once the producer is becoming free to produce data to get consumed by the consumer, then it will notify that same to the consumer. Okay, like yes, you are now available for consuming the data from the producer. So this should be implemented. So how we can implement this wait and notify method, that you can go ahead with it. Okay, so there is a separate post has been written in Geek for Geeks. You can go through that to how to implement this wait and notify. If you want me to create a separate video on producer consumer problem, you can comment it down below as well. Okay, so this is a problem that I already told you, like how can you simulate a deadlock situation and how can you resolve that with the help of coding. You can be asked this type of question in the interview, so you can go through that as well. Okay, implement a thread safe singleton class in Java using double check locking concept. So in normal single threaded application, there is no need to create this double check locking concept. But if there is like 4 threads, 5 threads, multiple threads are trying to acquire the lock, then what will happen? It will create a problem at the method level. Okay, so in that method level, you need to create double check of the instance, whether that instance is being created or not. You need to double verify it. So how you can do that? So you can have like, you can create a reference, you can put it like volatile, so that visibility is guaranteed across all the thread. Then within that get instance, within that method, you have to write 2 times, like if instance is null, then within that you need to synchronize that class. Within that you are writing that method, and then you are checking again whether that instance is null or not again. If it is null, then only create a new instance and return it, or else you don't create a new instance. So basically here what we are doing, if one time one thread is coming, if the lock is not being acquired, it will go inside because it's newly created thread. Okay, then after that it will see like, is there any other thread who has acquired a lock on this particular resource? No, so it will allow it to move ahead. But if second thread is coming and first thread has not released the object lock still, then second thread will go to the first if condition, like if reference is null or not. So that thread is coming for the first time, so it will allow to go inside. But in the second if condition, it first thread has already acquired the object lock and has not released it. So that's why second thread will not be allowed to move inside the second if condition. So it will go out of it. So synchronization is there for that to take care of these all things. So for this multi-threaded application, we can solve it with the help of double check locking concept. And how can we break it? There are three ways to break singleton. First is when we are when we are calling with the help of reflection. Okay, over a constructor, private constructor can be broken with the reflection. Okay, so we can solve it with the help of, we can have a if condition, like if the data is not being passed, if the instance is not null, then we should not create it. Like we can throw exception from there, or else we can create a enum. Through enum we can set the field values for that, the instances basically. So like that we can resolve this reflection issue. Then the issue can come with respect to deserialization. When you will serialize it, okay, the objects, and then when you are trying to deserialize it, then when you will check the hash code values, it will be coming as different hash code. Because while doing the deserialization, the class UID values will be changing. Okay, so that's why deserialization concepts actually changes the hash code of that particular object. So how can we resolve that? We can have a resolve method. To implement that resolve method, we can return the instance from that method and it will resolve that deserialization problem. Then with the help of clone method, if you are implementing, then it will create again, it will break the singleton. So for that, what we can do, we can return the instance from the clone method, and it should not allow clone method to actually clone the data. Okay, so yeah, so these are the things that we have to implement over there to actually stop singleton to get broken. Then importance of volatile keyword, I already told you, so that visibility gets guaranteed across all the threads in that particular application. Okay. So write a program where one thread waits for another thread to finish using the join method. Okay. So yeah, so you can write it down by your own. I hope it's not that difficult. You can create a thread. Okay. You can call join method from that thread, and then you can have wait and notify, and you can have a different set of methods with different set of processes you can execute, and then you can see like whether how join method is being working. Okay, so yeah, you can implement it by your own idea. Write a Java program where multiple threads try to increment a shared counter leading to a race condition. So how multiple threads are trying to access the one counter that has been implemented, and it has not been processed synchronously, so that multiple threads are trying to increase the value of that counter. Like counter value is 1, first thread is coming, increasing the counter, then second thread is coming, then third thread is coming, then within one loop and one flow of execution, multiple thread is trying to increase the counter value, so that it will create a problem basically. So we have to resolve it using synchronization. Just for deadlock we are resolving using synchronization. Similarly, when multiple threads try to work upon it, we can resolve it using synchronization. Similar to that we have done in singleton, right? Synchronized block we are putting it. Similar to that we can resolve it as well. Okay, I hope you can understood. You can go ahead and implement it. Okay, create a program where a daemon thread continuously prints a message where the main thread performs a task. So daemon thread will work when till the JVM is there. Okay, so if JVM is not exiting, daemon thread will keep on working. Okay, so you can set the thread as a daemon thread and you can keep on printing in that particular method. So it will keep on printing until unless JVM is there. I hope you have got it. I know you can now do it by your own as well. Okay. Use concurrent hash map to count word frequencies in a text file using multiple threads. This is very interesting question. Okay, so this question has been asked, I think once or twice to one of my friends. Okay, so there is a list of words defined in a particular text file, and then you have to read the data line by line by different threads using concurrent hash map. Okay, to try to implement it by your own, like how this concurrent hash map is working. There are certain methods within that we can implement it, and then there are multiple threads with the help of which you can synchronize it, and then with concurrent hash map you can implement, and then you can segregate the words within the text file, and you can count like how many times those words are being printed. Okay, I hope you got a clarity. So you can use concurrent hash map to implement this program. Okay, so there are two threads. We have to print characters alternately, like one character at a time. So this one I already told you in the freshers questions level, like how to do that. So one thread is printing A, second thread is printing B. So you can do with the help of wait and notify. Okay. Write a program to create a custom thread pool executor with a bounded queue and demonstrate its behavior. So custom thread pool executor. So normally it's fork join thread pool. Okay. Or else if it is not fork join, you can have fixed thread pool, cache thread pool. So you can take one example and you can see like how the behavior is being implemented over there. Okay. So if you just comment it down, I will create a separate video on executor framework and how those entire set of 4 executor pools are being working. That I will be helping you with that. Okay, so this is being particular for the fixed thread pool, cache thread pool, single thread pool, scheduled thread pool, how those things are working in a bounded queue. That for that you can implement a program for that as well. Okay, so this can be asked in interviews. They can ask to implement cache thread pool sometimes, or scheduled thread pool. So in scheduled thread pool also there are 2-3 different kind of methods that we have to understand. Okay, so go through that. If you face any kind of issue, do comment it box. I will be helping you with that as well. Optimistic and pessimistic lock concept is also there in the lock. Okay, so synchronization is there, then lock is there. Within lock, there can be optimistic lock and pessimistic lock. Optimistic, like it's very much optimistic, like the lock has been provided. That means lock is there, it is synchronized, but that may or may not be synchronized. But that is optimistic that particular lines of code is synchronized. Okay, so this is very optimistic lock. And pessimistic lock means we have provided synchronization, but it is thinking like that particular lines of code is not synchronized and it will not be working concurrently. Okay, so that is pessimistic lock. So how it is being implemented, that you can go ahead with, like what is optimistic lock, how it is working, what is pessimistic lock, how it is working. With some small piece of code you can understand that. Okay, so this is a concept basically that we have to go through. Yeah, so if synchronized keyword was there, then why lock came into picture? Basically, the difference between synchronized keyword and lock that you have to go through. So lock basically can go from one scope of the one method to another scope. Okay, it is not fixed with one method scope only, but synchronization is fixed with that particular method. It cannot go to another method scope. Okay, and lock, we can lock in one of the method and we can unlock in another method, but synchronization has to be locked and unlocked in one method only. Where you are starting the synchronization block, that is a starting point of lock. Okay, and when you are closing the braces of synchronized, that point it's actually unlocking the lock. Okay, so this is the entire concept of synchronization, which is at the method level or at the instance block level, but it cannot be transferred to another method, which is there in the lock. You can lock in one method and you can unlock in another method as well. It would a calling method. So like that it will flow. When to go for runnable and when to go for callable. I hope you have got the answer for this. So when you want to return some data back to the caller method, so in that case, you can make use of callable because there is a return type attached with a callable. Okay, and when you have to handle some kind of exceptions over there, then you can go ahead with callable. Runnable is to be used when you don't want to return any data to the caller method, but you want to execute the process or a task in the run method in that particular method only. Okay, you don't want to return anything, then you should go for runnable. Yeah. I hope you got the entire set of questions that can be asked in interviews. If you just practice these questions, believe me, you will be very much be prepared for your interviews. Yeah, whatever programmatic question that I have discussed in this, try to practice it by yourself. Try to do it 2-3 times. Try to revise it because those type of questions are asked. And versus like this versus that. So lock versus synchronization, optimistic versus pessimistic lock. There is half lock, there is half open, half close. What's the meaning of that? Okay, in circuit breaker there is half open, half lock. Okay, so these kind of questions that can be most commonly asked. Okay, so how can we implement like read write lock and reinvent lock? What's the difference between the two? Practice these type of questions only. Whatever we have discussed in this 40-50 minute session, you can just go through that and believe me, it will be a very easy cakewalk for you to clear any kind of multi-threading based questions in the interview. I hope you have been clear till now. I hope you have learned a lot from this video. If you have learned, please like, share, and subscribe. It's mandatory. Okay, I'm just telling you, like if you are liking it, please like so that YouTube will push my video to wider audience, and please share to those who need this question set because these are very important, specifically for freshers. Okay, I hope you got a clarity on it. So we'll be seeing you in the next video in the next set of concepts. Till then, it's Devjit Roy signing off. Bye bye.